this is Miss Kierstead, and today we're going to look at trigonometry sort of in a different way than using triangles necessarily, and definitely outside of right triangles. So we're going to start first with a little investigation. I want everybody to have a calculator, and I want you to find these trig ratios using your calculator. So hopefully you are back from having done this, and when I did cosine of 30 on my calculator, I got 0.866. When I did cosine of 150, I got negative 0.866. When I did 210, I got another negative 0.866. And when I did negative 30, I got 0.866. Now, when I think about this and finding these ratios, something really odd comes to my brain, because I know that when I'm doing trig, right, the cosine of 30 degrees means that if I had a right triangle with a 30-degree angle, the ratio of the adjacent to the hypotenuse would be 0.866, which means I could do 0.866 to 1. But then when I think about how do I do a right triangle with an angle of 150? Well, if I have a right triangle, it's impossible to have an angle of 150, or to have an angle down here of 210, or to have an angle of negative 30. So my calculator gives me these ratios, but what do they mean? So we're going to start by saying, where do these things come from? That's going to be the next few videos. We're going to investigate this, right? Because I know sine, cosine, tangent ratios work when we have right triangles. How can I have a trig ratio if my angle is bigger than 90 or my angle is negative? So to start off, mathematicians have decided we can put angles sort of on our coordinate plane. So, and there's this thing called standard position. What the important parts is you have an initial side of my angle. So we're going to start my angle always right here. This is the initial side, and it's on the positive x-axis. Always, 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 okay? And then to create an angle in standard position, I am going to go counterclockwise around. So for a positive angle, I go counterclockwise around. So if I had 30 degrees, I would go 30 degrees here, boom. And this is what's called the terminal side, because it's where my angle ends. So initial side, terminal side, okay? Now, one thing is you can have angles, and so you can think about this is where 0 degrees is right here. This is where 90 degrees would be, because if I went straight up, I'd have a 90-degree angle. But I can, if I do this, I can go bigger than 90, right? If I wanted to go 150, I could start right here. Here I'm going around 90 degrees, 150 is going to be somewhere here, because I know this would be 180 degrees. So 150 would be somewhere over here. And if I want to think about my 210, right, again, I'd start here on my initial side, always here, and I'd go, there's 90, there's 180, 210 is going to be somewhere down here. That would be 210 degrees, okay? We can even go more than 360, right? I can go around more times. Let's clear this off. What if I had an angle, say, of 309, or let's go 400 degrees, okay? So I would start here, boom, right here, and I'm going to go around and around and around and around, and there's 270, and there's 360, and if I want to go 400, I'm going to go some more, and this would be 400 degrees would be right there, because I went past 90, I went past 180, I went past 270, and I went past 360. So this was both 0 and 360. And that's called standard position. One more thing we can do is have negative angles. So that's how we can have angles bigger than 90, but we can also have negative angles. So if in negative angles, we are going to start the same way. So what if I wanted negative 30 degrees? I'm going to start right here, shoom, 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 and I'm going to go backwards. I'm going to go clockwise. Right, so I'm going to go this way 30 degrees, and I'm going to end here. And this is going to be my terminal angle. Okay? Right? So now let's practice. So I'm going to draw the angle in standard position. So I'm going to think it's helpful to kind of know this would be 90, this would be 180, this is 270, this is both 0 and 360. So as I go around, I'm going to start here, always start right here, and I go, I go past 180, I go past 270, and I end somewhere in here, and that's my theta. I could do 250, right? Maybe you should pause the video, see if you can draw an angle of 250 in standard position. So I'm going to start here, oops, and I'm going to go past 90, and I'm going to go past 180, but I'm not going to go all the way to 270. I'm going to stop, I'm going to terminate. There's my terminal side before I get to 270. Okay, I can do negative 150. So for negative 150, again, always start going out this way. And then negative angles, I'm going to go this direction. And I'm going to go past negative 90. This would be negative 90. And I'm going to keep going past negative 180. Oops, no, I don't want to go past negative 180. I want to stop somewhere before that. Oops, somewhere right about here. And that would be negative 150. That would be my theta from here to right there. And again, I can do 390. That's going to be more than once around, which is crazy. But again, I'm going to start here. And I'm going to go 90, 180, 270, 360. I keep going. Boom. And that would be an angle of 390 degrees. So mathematicians created standard position angles in the coordinate system. And then another video, we're going to talk about how we do trig ratios now for this. So hopefully you can now draw an angle in standard position.